Hello everyone. In this video, we will continue to work with a few more examples of derivative of transcendental functions. Before I get into that, I would like to mention to everyone the process of taking derivative of a transcendental function. Taking derivative of transcendental function remembers that each of these trigonometric functions will have a result as another trigonometric functions. So you have to apply this basic rule plus you have to multiply the result with derivative of the argument. Alright, so there's a involvement of power rule, product rule, or quotient rule, then we have to apply that as well. So in previous lesson, what we have done is we working with derivative of transcendental function, and we work with power rules. We work with tangent, cotangent, secant, and cosecant, and we work with power rule in this case. And I emphasize to everyone that there's always 3 steps. So you apply the power rule first, then you take derivative of the trigonometric function itself, and then you take derivative of the argument. And all of the 3 steps, all the 3 results are multiplied with each other. And in the end, we simplify. Alright, so we did a few examples with this, and then in previous video we also did the derivative of cos and sine, and in this question here I have like a derivative of sine, but the argument of sine is actually another trigonometric functions. Okay, so I don't want you to get confused because of the 2 trigonometric functions involved in this case. So just remember that the argument of the sine function is another trig function. So the same concept apply. Alright, so if I move on to question number 11, like I have mentioned to everyone, that we will have 3 more questions to finish this derivative of transcendental function lesson. So for this example, you see that you have a cosecant of a trigonometric function. So basically, it's actually very simple. In this case, there's no power rule because you don't have any power beside this cosecant. All you have to do is just apply the derivative of cosecant, and then after that, you multiply by derivative of sine of 5x. Alright, okay. So let's get started with that. Okay, so before I write anything down, I would like everyone to take a look at this formula sheet right here. Okay, so what is derivative of cosecant? Derivative of cosecant is negative cosecant times cotangent of the same function and multiplied by derivative of this argument, and the argument is sine. And so what is derivative of sine? Is derivative of cos. Is also this formula number 1 and this formula number 6. We have to know how to work with these 2 formulas. Alright, so I will write dy over dx because as I remind everyone that as soon as you start differentiating, you need to write dy over dx. Just don't just write just an equal sign. Okay, so make sure that you tell me or tell the reader that you are going to differentiate. So you apply the derivative of cosecant, so it will be negative cosecant, okay, of the exact function again, and then multiply by cotangent of sine of 5x. Okay, so this is just the derivative of cosecant. Now you are going to take derivative of sine of x and you multiply with that. So what is derivative of sine of x? It's just cos of 5x. Alright, okay, and this will have to multiply by derivative of 5x, which is 5. So what I'm going to do is I will write the number 5 right there. Okay, so just want to remind everyone, this one is the derivative of cosecant function, and this is derivative of the argument. Okay, so you don't have any power rule in this case, right? So in the end, you just simply write your answer as negative 5 times cos of 5x, okay, and multiply by cosecant of 5x of sine of 5x, I'm sorry, and then multiply by cotangent of sine of 5x. Alright, okay. So that's simple because we don't have any power rule in this case. So let's continue with number 12. So again, for this number 12, we are having negative 5 divided by this trigonometric function underneath the cube root. Okay, so in this case, you see that you are raising a trigonometric function to a power here. And do we need to apply quotient rule in this case? Because you have the two divided by each other. In this case, I recommend everyone is we are not going to use the quotient rule. All you have to do is just rearrange your denominator to write it as a numerator, and then you do the correct process of converting the exponent. Okay, so now the next step I'm going to write is just y, because I'm not going to differentiate yet, because all I do now, I just want to rewrite my function so that I can present my exponent properly before I can apply any rule to this. So you will write it as, so before I do that, I will write it as negative 5, okay, the whole thing divided by cotangent of x squared plus 2x. Alright, so, and all of this, I will raise this to the exponent here of 1/3. Okay, so don't forget that it's exponent 1/3. So what I'm going to ask you to do is here I will write negative 5 times cotangent of x squared plus 2x, all of it in the bracket, and all of it I will raise to the exponent negative 1/3. So let me give myself some room and rewrite this. So I will write y equal to negative 5 times cotangent of x squared plus 2x, all of it raised to exponent negative 1/3. Alright, so when I write negative 1/3 like this, I would like to write the negative 1/3 on top of my cotangent trigonometric function. Okay, so I will rewrite this as negative 5 times cotangent of negative 1/3, and then the argument is x squared plus 2x. Okay, all of it in the bracket. So don't forget that this cube root applies for this entire cotangent of x squared plus 2x. So therefore I have to raise all of it to exponent 1/3, rearrange, bring it as a numerator, change to the negative 1/3, and to make it easier for me, I write the negative 1/3 beside my cotangent. Okay, so don't forget that this symbol right here, when you analyze your exponent, the exponent applies for the entire cotangent function. So don't make the error that this exponent only applies for this argument. Okay, so it's totally different as in previous example that I have explained for everyone. So let me go back to that previous example. We did a difference between the two in this case, you see, so tangent to the exponent 4 of this, okay, is the same as you are writing it like this. And it's totally different if you actually take this 4 and put it right as your argument. To do it will change the entire functions altogether, and when you differentiate that, your answer is actually totally different. Okay, so in this case, the correct exponent is negative 1/3, and it applies to our trigonometric function of cotangent. So now you see that you have to apply the power rule for this cotangent to exponent negative 1/3. So that's your step number 1. Step number 2 is take derivative of cotangent. Okay, and don't forget, it's just the straight derivative of cotangent. You don't have to worry about the negative 1/3 and negative 5 anymore. And then the very last step is to multiply with derivative of the argument. Okay, so my next step, I will write dy over dx now, right? Because I'm going to differentiate. So I will take negative 5, I multiply by negative 1/3. At the same time, I will take 1 away from the exponent, which is 1 take away from negative 1/3 will give me negative 4/3. And I write the argument again, the exact argument again. So if I make a note of this, I will tell everyone that this is the power rules. Okay. Okay, my next step is to multiply by derivative of cotangent. So what is derivative of cotangent? So we are going to go to our formula sheet. I know that cotangent is negative cosecant to exponent square, so it's right here. Okay, so if you remind yourself of this formulas, then you see that you have to multiply by derivative of the argument as well. Okay, so take a look at the formulas, and then it's a reminder for us that you still have to multiply by derivative of the argument. Okay, so I will write a negative cosecant square of x squared plus 2x. Alright, so this is my derivative of cotangent. Okay, so you just take derivative of cotangent itself. You don't have to repeat the exponent. You also don't have to repeat the negative 5 because you already take care of those, the exponent and the coefficient, by applying the power rule. So this one, just straight derivative of cotangent. And the next step is I will multiply by, okay, derivative of the argument. Okay, so this should be derivative of the argument. So the argument in this case, x squared plus 2x. So I should have 2x plus 2. So I also would like to make a note to everyone here that I can factor out the 2. So I will have x plus 1. Okay. And since I take out the 2, I will multiply 2 with the negative 5 and negative 1/3. So in the end, my simplified answer should look like this. Okay, so it should be negative 10, okay, x plus 1. And what I have is the 3 will go down to the denominator. On top, I should have cosecant square of the argument of x squared plus 2x. And I will bring cotangent of to the exponent negative 4/3 down to the denominator and make that a positive exponent as required. Okay, so cotangent to the 4/3 of x squared plus 2x. So that's my final answer. I don't think I can simplify any further. Okay, so another note for everyone. Okay, so I will write a note like this. So I will write negative 5 times cotangent of negative 1/3 of x squared plus 2x is not the same as negative 5 cotangent of x squared plus 2x raised to the negative 1/3. They are totally different from each other, and I don't want you to make the error. And then if you differentiate this, you can see that the answer is totally different. In this case here, you don't have to apply the power rule at all, but you need to apply power rule for the argument. Alright, so therefore it's totally different. Okay. Alright, so I kept repeating myself regarding the exponent for the trigonometric function or the exponent for the argument. So I hope I emphasize enough regarding the difference between the two. Alright, so let's move on to our next example. Question number 13. So I have sine, derivative of sine, And the argument of sine is another function as secant. So in fact, it's very simple. You probably can do that in just a few seconds. You can finish this question in a few seconds because we have done quite a lot of example regarding the transcendental function already. Okay, so in this case, you realize that there's no product rule at all here. The secant 2x squared applies as the argument of sine, and there's no power rule. So all you have to do is just take derivative of sine, repeat the same argument, and multiply by derivative of the argument. So basically, this question number 13, all you have to do is just apply the formula number 1. Okay, and then you apply the formula of what is derivative of secant, which is equal to this. So 1 and 5, the two formulas that you have to apply. Okay, so dy over dx will be equal to cosine of secant of 2x squared. So this will be my derivative of the trigonometric function. And now I will multiply by derivative of secant, so it will be secant 2x squared multiplied by tangent of 2x squared. And the next step is to multiply by derivative of the argument, which is 2x squared. So in this case, it's just 4x. So I will make a note here. Okay, so this is the so I should make a note. This is derivative of sine. Okay. Then this is derivative of secant, and this is derivative of 2x squared. Okay, so in the end, my final answer should be 4x times secant 2x squared tangent of 2x squared, and then cosine of secant 2x squared in the bracket. And that is the final answer. Alright, so let me go back and kind of summarize what we need to do in this case. Okay, so I'm sorry, excuse me. So derivative of sine, cosine, tangent, and cotangent. Okay, you can see that they you need to take a look at this formulas sheet that I have provide for everyone. So and recognize what formula to use and understand the formulas. So the basic formulas, basic concept is this: if you have derivative of a transcendental function, each of these transcendental function will have a result as another trigonometric function. And at the very last step is always multiplied by derivative of the argument itself. And then it's in different form. In the form of where you have to apply power rules, or you have to apply product rule, quotient rule, but sometimes you don't have to. Okay, I don't believe that I have done any question involving transcendental function with the quotient rule. Let's get back to our page. Alright, so in this case, what you do is the strict formulas you apply here. There's no power rule at all. Okay, so the next one is also no power rule. Just apply the derivative of cos and then multiply by derivative of the argument. So for this question, I emphasize the exponent, and the exponent for the argument and the exponent for the trig function. So there's a difference between these two, a huge difference. So I differentiate this for everyone. So derivative of sine is just cos and multiply by derivative of this argument x to the exponent 3, which is a function raised to a power. And then for this part, if you see derivative of a trig with the exponent, That means you have to apply 3 steps. Apply power rule for this trig function, apply derivative of the trig function itself, and then apply the derivative of the argument. And at the end, the 3 of them, the 3 results will multiply with each other. Okay, and in the end, you see the difference between the result here. Okay, so I would like everyone to make sure that you note that. Okay, and then we come to an example where you have the derivative of a function raised to a power right away. So in this case, you see I apply the power rule. Then after you apply the power rule, you forget about this exponent. You just take the derivative of cos with the exact argument. Okay, and the last step is to multiply derivative of the argument, and we have done quite a few questions about derivative of this type already, so it's just a quick review for everyone. In the end, we still have to write it as positive exponent and then simplify our answer and write it properly. Alright, okay, I did a product rule. So in the case of a product rule, we will have to apply these formulas. So this is quite simple because it's just a two simple cos and sine function. The sine of x squared, cos of 2x. So in this case, it's very easy to recognize that x squared is the argument of sine and 2x is the argument of cos. And you can distinguish there's two trigonometric functions here and they multiply with each other. Therefore, we apply the product rule. Okay. And for this one, you have derivative of a trig function, but the argument of that is another trig function. So in this case, the same concept apply. Take derivative of this trig function and then derivative of u, and your u in this case is the cos of 2x. Then what is derivative of cos 2x is the another trig function and multiply by derivative of the argument. Alright, okay. So and then we done question with the tangent, cotangent, and secant. So again, I emphasize that with the power rule, you make sure that you apply power rule here, derivative of the trig function, and then derivative of the argument, they all multiply with each other. Okay, I also emphasize the difference between the exponent for the trig and also the exponent for the argument. They are totally different from each other. Okay, so a little bit more complicated with the in terms of the argument here, that we have to know how to differentiate properly because of the 2 inside the square root. So I want everyone to make sure to be mindful that you understand the notation and also how this radical is supposed to work in terms of turning this into a correct exponent. And if you work with secant and cosecant, so in the end you will have 2 secant here, right? Then you should combine to make it to 1 secant to exponent 5 in this case, because this is 4 and this is 1. Okay, so the secant to exponent 5 of this argument coming from, you are combine these two. Okay, doesn't mean that you can skip this step and then you just rewrite the exact same thing again. So I don't recommend that because all the rules still apply. Power rule, derivative of cosecant, the derivative of the argument, they all multiply with each other. Then you can combine the like term or multiply the 2 powers with the same base. So in this case, secant to the 4 and secant to the 1, you can combine and write it secant to the exponent 5. Alright, so again, the same concept apply. Be mindful of your square root of a function and convert that to the correct exponent. For this one is this derivative of a trig function, but the argument of this trig function is another trig function. And for this particular part, so a bit more complicated with the cotangent raised to exponent 1/3 and then to the negative 1/3 and apply properly with the exponent here. Make sure the negative 1/3 apply to your trigonometric function and don't assume that this 1/3 is only for the argument. Okay, so the way it's written like this, it means that the 1/3 is for the entire cotangent of this function, and it's not for the argument. Okay, and there are 13 questions altogether for this lesson for derivative of transcendental function, excuse me. And I think I cover most of them. And I don't ask you to have to know the quotient rule for this type. So I hope that you will go over the video one more time. And after you finish all this, you can work on most of the questions that I designed here for everyone. Okay, so these are the practice at the end of this lesson. All right, okay, and the solution for all of this question is actually posted on Blackboard. All right, thank you everyone.